Okay, this is the first lesson in chapter 3, and this covers some properties of equality and algebraic transformations. And what you need to know about this is that when they talk about properties of equality, or they talk about algebraic transformations, basically they're just talking about solving equations. Okay, so properties of equality all have to do with equations, although some of them also apply to inequalities. And algebraic transformations are different than geometric transformations, which are like translating and rotating. Those are geometric transformations. Algebraic transformations is just rearranging an equation or an inequality or a formula. Okay, so we're going to solve equations using addition, subtraction, multiplication, and division. So there's a lot of vocabulary in this lesson, so please make sure that you're reviewing it. So the first one is equivalent equations, and they're just what they sound like. They're equations that have the same solution set over a given domain. So here's some examples. X minus 8 is equal to 17, and x equals 25 are equivalent equations. And if you were to solve this equation for x, you would get x equals 25. So it's the same thing, it's just in a simpler form. Same with this one, we have negative 5 is equal to n plus 13, and negative 18 equals n. This equation is just this one basically solved or simplified. Okay, so that's what equivalent equations are. Properties of equality are the properties that allow us to solve equations. And the main thing you need to know about properties of equality is that what you do to one side, you have to do to the other. Okay, so here's some examples. We're going to say that if A is equal to B, so these two sides are equal. The addition property of equality says I can add the same thing to both sides and it'll still be an equation, it'll still be equal. The subtraction property of equality says I can subtract the same thing from both sides and it'll still be equal. The multiplication property of equality says I can multiply both sides by the same thing and it'll still be equal. And the division property of equality says I can divide both sides by the same thing and it'll still be equal. Okay, so these are things that you already knew you could do. These are just the names of the properties that allow you to do them. Okay, so they're all properties of equalities. So whenever you hear something that talks about a certain property of equality, know that it has to do with solving an equation. Okay, it is often possible to change or transform an equation into a simpler equivalent equation, which is what we do when we solve, by using substitution or the addition, subtraction, multiplication, and division properties of equality. So here I've cheated, and I've, instead of writing them out each time, I just did initials. So this is the addition property of equality, subtraction property of equality, multiplication property of equality. Okay, and on the back is probably division. Okay, so we're going to transform these equations by adding. So for this first one, I want to get W by itself. I'm subtracting 11. I can undo that by adding 11 to both sides. And I'm left with W is equal to 15. Okay, so I have transformed that equation. The first equation and the last equation are equivalent to each other. Okay, and this one is just basically simplified or transformed. Same with this one. I have negative 4 plus y equals 0. I want y by itself. I am currently subtracting 4. So I'm going to add 4 to both sides, and I get y is equal to 4. If I plug it back in, negative 4 plus 4 is equal to 0. Same with this one. Everybody freaks out when they see fractions. Fractions are just numbers. They have feelings too, so be nice. Z minus 1/4 is equal to 1/4. I can undo this by adding 1/4 to each side. And I get Z is equal to 1/4 plus 1/4 is 2/4 or 1/2. See, that wasn't bad. Okay, now we're going to look at the subtraction property of equality, which means that I can subtract the same thing from both sides and it's still an equation. It's still equal. So here I have x plus 5 equals 9. I'm adding 5. I want to undo that by subtracting 5. So here I have 9 minus 5, which is 4. If I plug it back in, 4 plus 5 is equal to 9. And it's always a good idea to plug your answers back in just to make sure that they're correct, especially when you have positives and negatives. A lot of times you'll have just the sign wrong, and if you plug it back in, you can figure that out. So here I have 1 is equal to a plus 9. I want to get rid of the 9, so I'm going to subtract it from both sides. And here's what I was talking about. We have negatives. So 1 minus 9 is the same as 1 plus a negative 9, which is negative 8. So if I plug it back in here, negative 8 plus 9 gives me positive 1. Okay, so go back and check. Here's another fraction. 4/5 equals 1/5 plus d. I'm going to subtract 1/5 from both sides. I'll just have d over here. And 4/5 minus 1/5 is just 3/5. Do not change fractions to decimals. The only time we do decimals is if we started off with decimals or we're doing a word problem that would require decimals, like something that has to do with money. Okay. Otherwise, you have to keep it as a fraction. And the reason we do that is because fractions aren't rounded. Most of the time when you have a decimal, you end up having to round it. Okay. Whereas so a fraction is more exact and you can do more with it. Okay. And we'll get to that later. All right. Now we're doing the multiplication property of equality. And that basically says that you can multiply both sides by the same number. So multiplication undoes division. So here you'll see our division, and we write division as a fraction in algebra. So if you remember how to get rid of the fractions, we're going to use the property of reciprocals, okay, which says if you multiply a number and its reciprocal together, you get 1. So I want to change this negative 1/10 to a 1 so that it's just 1r or r. So I have to say, well, what's the reciprocal of negative 1/10? Well, the reciprocal of negative 1/10 is negative 10 over 1, or just negative 10. So I'm going to multiply both sides by negative 10. Make sure that you use the sign. The reciprocals have the same sign. So this just cancels out. The negatives cancel out, and I'm left with r. Here I have 5 times negative 10, which is negative 50. Okay. If I were to check this, remember that this is the same as this. So I could say, well, negative 50 over negative 10 is equal to 5, which is what it was. Okay. Again, for this one, the reciprocal of 1/2 is 2, or 2 over 1. I write it as 2 over 1 on the side that has the fraction, but I just write it as 2 on the side that doesn't have the fraction. So I end up with b is equal to 8. So 1/2 of 8 is 4. That makes sense. Here, think in terms of this. You can separate that out. Remember that one property that said you could kind of separate your fraction into factors? So I can pull that 5/3 away from the y. Okay, it would be the same as y over 1 or just y. And I would put a 1 over here. And so I would multiply both sides by 3/5. Okay, so these cancel because those are the reciprocals. And here I have 3/5 times 5, but the 5's cancel, and I end up with just 3 and 2 equal signs, which is weird. Okay, so if y is equal to 3, check it. 5 times 3 is 15. 15 divided by 3 is 5. Okay, so get in the habit of you don't even have to write it down. Just mentally check your answers. All right. The next slide, now we're looking at the division property of equality, which says we can divide both sides by the same number. So here I'm multiplying, and I want to undo division. Now make sure when you're undoing multiplication and you're undoing division that you're using the same signs. So if the number that I'm going to get rid of is negative, then I have to multiply or divide by a negative. Okay, so here I have 5y, or 5 times y, equals 15. I'm going to undo this multiplication by dividing by 5. And notice I just write it as a fraction. I don't use this sign right here. Okay, we don't do that. Just write it as a fraction. And then you would simplify it. So it might not simplify to a whole number. It might just simplify to a fraction, which is fine. We want to leave it as a fraction. So this becomes 15 divided by 5, which is 3. And if we check it, 3 times 5 is 15, which is what we started off with. Okay, this one, don't let the 0 fool you. Just pay attention to what you're doing. 0 is equal to negative 4 times k. I'm multiplying k times negative 4. I want to undo that, so I'm going to divide both sides by negative 4. Now, I'm allowed to divide 0 by anything. I just can't divide by 0. It just so happens that 0 divided by negative 1/4 is still 0. So k is equal to 0. And if you think about it, negative 4 times 0 gives you 0. Okay, in this last division, we're multiplying both sides by negative 25. So I'm going to divide both sides by negative 25. Remember the sign, you want to get rid of the sign as well. So this just becomes p. Negative 75 divided by negative 25 is positive 3. Okay, so those are just basic one-step equations, undoing using inverse operations. Okay. There's also transformation by substitution. and we substitute an equivalent expression in a given equation. So in this case, I have two equations. This one says 2x plus y is equal to 7. So I have two different variables, x and a y. And the rule is that the number of variables tells you how many equations you need in order to solve it. So in order to solve this equation, I actually need to have a second equation because there's two different variables. And here's my second equation, which tells me that x is equal to 4. So what I'm going to do is I'm going to substitute in the 4 for the x, because I know that x is equal to 4, and I've been told that these two x's are the same. Okay, they're not just arbitrary numbers. So I plug in the 4, and now I can solve for y. So I'm going to have 8 plus y equals 7. I can subtract 8 from both sides, and I get y is equal to -1. So if y is -1, let's check it over here. So I have 2x plus y equals 7. We said that x was 4. We said that y was -1. So we get 8 plus -1 equals 7, which is true. Okay, so again, just quickly check. This one had a sign. It doesn't hurt to check it. All right, so you're going to do this, to try this. They're just basic equations that you're going to solve using the properties of equality.